Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is yet another explainer. An explainer about how we can use metrics to predict instead of estimating. This is something that some people call no estimates, but don't think too much about this term, because basically what we want to do is not necessarily to talk about no estimates. What we want to do is to talk about alternate method of prediction. And this is what we'll be discussing today. And before we go, let's talk a bit about this tweet. This is a tweet by Vasco Duarte, and he talks about the fact that there are three critical logical fallacies that people make when they think about estimates. First one is people think better estimates get you more predictability. But if this were true, all transportation systems in the world would spend millions on estimators. Instead, what they do is measure and repeat. So we can use, fundamentally, maybe we can use the same principles. They measure past performance, assume similar future performance. For example, the drawing a bus, train, air traffic timetables. So what happens is you measure how long it takes for buses to go from one place to another, and then based on that build the timetables, and then look at how you can improve. The second, people think that estimation can help remove the problems that come with dependencies, that estimation can help plan better dependencies, and Vasco states that instead, the more you estimate, the more errors you build into the planning, leading to catastrophic errors. I think here what he's saying, and he's qualifying this a little bit, the problem is that estimation errors grow exponentially in a network of dependencies, and estimation errors are never recovered by being faster with other work. And it goes into more things, but the fundamental idea here is that when you make a plan, you make some assumptions, and those assumptions are built into the plan. It's very hard, well, I would say it's impossible for people not to make assumptions when making plans or anything else. There's always a bias, there's always an assumption that, or a set of assumptions that you're building upon. You can do a better job of making those assumptions explicit and then trying to remove as much bias from your results. But what we are trying to do is to build software, right? We shouldn't need to be very scientific about the methods we are using to estimate, but focus more on the method we are using to build, right? Because we want software that works and does what it's supposed to do. And the third, people can assume you can plan everything, otherwise estimates make no sense whatsoever. Instead, we never know what the everything is until we start delivering. So in fact, delivering something is more important than knowing what is everything that we need to deliver. Now, this is true for some projects, is not true for other projects. For some projects, it's quite clear what we know, what we need to deliver. Maybe not fully, because things always change little by little once we go into the actual development and we show our product to people and people start using it and so on. But there are certain areas where things are more predictable than others. And so this sentence is not always true. It's true in the Kinevin complex domain, when you are having problems that fit the complex domain, not problems that fit the ordered domains. So yeah, not always true, but sometimes. Okay, so let's go into the explainer. So what we are trying to do is to discuss a little bit about metrics-based prediction over estimation. And we are saying that estimation in software projects is challenging. I think there's no question about that. I think we've all been in projects where we've estimated something and then for one reason or another things have not gone as we expected in the beginning. Maybe we didn't take the estimation seriously in the beginning and just gave some numbers. Or if we try to estimate properly, we realize that we have a lot of things that we don't know and we needed more answers. And some of those answers were actually found while developing and learning more, so on. So there are a lot of challenges. And so the question is, can we predict based on past metrics? And what I'm going to explain is a method that uses cycle time to do that. And I'm pretty sure it's not the only method, but let's explain this one and maybe you can try to use it. You can even simulate it if you have enough data and see if it would work better than what you have or if it would work the same as what you have but with less work. So I'm not saying that this would work in any context. Maybe in some contexts it's still better to estimate a bit more in the beginning. It's up to you, right? It's up to you. This is not like any advice in software development. Everything is contextual. So this works in specific contexts. And the general advice here is to try it for yourself, see if it fits your context or not. And the way you try it for yourself is once again by simulating based on past data, if you have such data. Or you can do this in parallel with your normal estimation for a while and then figure out whether it works better or not. So there's very little work to be done, but there is a potential advantage. So why not try it? Okay, so let's see. Estimation challenges. Why is estimation challenging? Well, because we have a bias. And let me explain a little bit what we have here. When we start a project, it doesn't matter what type of project, but we'll focus on software. Software development is about knowledge. And we need to, fundamentally what we need to do is to take knowledge that is very unclear, very unrefined, and refine it all the way to code which is very precise, right? Code is encoding knowledge. So what we are doing is basically refining knowledge inside of a team. And this goes through multiple steps. And because we are talking about knowledge, what happens is that we need to take into account these metrics of known and unknown, knowns and unknowns. So in every software project, we'll have known unknowns, things that are very predictable. Like, let's say we've done 10 projects using Spring MVC. And now we are doing the next project using Spring MVC. So we pretty much know how to use the framework. This is one known, right? We've hit most of the challenges, we've gone over them, we've learned a lot of things about them. Now, what if we've done 10 projects using Spring MVC, but now we need to do a new project using AWS Lambdas and micro frontends? Well, we have some known unknowns. We've never done that worked before, but we have a few open questions, we have a bunch of risks. The open questions would be things like, okay, how do we implement a simple AWS Lambda? How do you deploy it? How do we test it? How do we update it? What can we use to implement front ends? What is the architecture of micro front ends? And so on. So these are some questions that we can identify at the beginning of the project, or in case we are splitting the work into sprints or something else, in the beginning of the sprint. It doesn't have to be in the beginning of your period of development. And there are ways of dealing with these open questions, like you can do some research, you can go to a training, you can do a spike, implement a prototype. So there are various ways of dealing with known unknowns. Now, what you don't know is how long it will take you to solve these known unknowns. You know that you have them, but it's unclear how long it takes you to actually fix them, to solve them, to get the correct answers. So this is already a perturbation in your estimation, because this might go, 2 times, 3 times, 4 times, 5 times, 10 times. We don't know how much it will, how long it will take us to get over these questions. The next quarter is unknown knowns, which is a bit weird, but it's basically when you have a nice surprise. So let's say you are using, you are discovering that you can use Spring MVC to implement AWS Lambdas, and it's just a matter of configuration or adding another tool on top, and it just works. Cool. So if you're doing that, then you didn't know you knew that, but suddenly you know it. So it's easy. And that is a nice surprise. This happens. So this has the other effect on your estimates. If your estimates were taking into account like extra things that could happen, extra risks, with the unknown knowns, you get positive. Your estimate will actually be, or your time to implement things will actually be smaller than your estimate. So that's great. But then where things get really tricky is unknown unknowns, things that you don't know that you don't know. These are assumptions that you make. So for example, you might say, okay, we are using Spring MVC, but there is a feature there that looks very easy. Let's say implement a report or something like that. But then you realize that you don't know how to do that in Spring MVC. And you only realize that when you start working on that feature. Okay? Or maybe, that you need to learn some other things, some other technologies, some, maybe they are asking for you to use LaTeX to build something, and it wasn't clear in the beginning, so now you have to learn LaTeX in order to create documents. I'm just saying. So this is the oops area, right? It's the area where you have the most problems. And now the problem is that we are biased. And there are various biases in the team, which is good. Some people have a positive bias. So even though let's take this case, we know that we've never done this before, but we're very good, so we'll do it quickly. And this is a challenge. Okay, I've seen some people who are very, very optimistic and they trust their own learning and their own knowledge.
extremely well, and they will say, "Oh, we'll definitely do this quicker than we assume. It will take us, as usual, even though we have to learn some more things." All right, so this sounds to me like an bias towards optimism. Usually, sometimes it's granted, especially for people who have learned how to learn. They know how quickly they learn things, and in that situation, they can get very quickly at the right, learning new things. Another bias is we've never done this before, but our customers need it, so we'll get it done fast. Basically, a bias on the pressure, or let's say not pressure, but sometimes it's motivation to get things quickly done for customers because they need them. And yeah, this might be true, but not always. So this is why it's a bias, right? Sometimes it's true, but sometimes not. I've also seen the other type of bias, the pessimist bias, which is, so it will take us 10 times longer than predicted. Now, 10 times sounds a lot of pessimist. Like, so we don't want to be that pessimistic. We don't want to have that negative bias. If we know how long it takes us to learn things, we'll probably get there faster than 10 times. Maybe it will be 1.5 times. Okay. Maybe it will be 2 times, but usually 10 times that's reserved to very, very complicated things. So this leads us to the challenge that one day is never precisely one day. So when an optimist says one day is, we estimate one day, this might be actually 4 days. When a pessimist says, I'm estimating one day, it might be actually 2 hours, right? So one day is never precisely one day. And this is the big challenge with estimates. Now, the way we are dealing with this in Scrum usually is with planning poker. And planning poker is a way to bring our biases together, discuss them, and then hopefully they cancel each other. We clarify a bit more what we need to do, and as a result, we get a very good or a more precise outcome, right? And that's one way of dealing with this. And that way is fine. On the other hand, that requires, let's say, it's not always the most pleasant ways of estimating, and sometimes planning poker works really well with a team that is mature and with a team that is not needlessly pressured by the product owner and the business people. But sometimes when you get the other type of bias, when you get pressure, outside pressure and so on, the results might not be that good. So yeah, maybe there are better ways. So how about using past performance instead? And this is something that has been used in the past, and it's being used. We mentioned already schedules for trains, planes, but in addition to that, weather used to be predicted like this. It was basically yesterday's weather. So the paper would print yesterday's weather as the expected, weather for today. And this works actually pretty well. In fact, I'm using this almost every day. I don't like to watch temperatures and all that, so I'm always, most of the times I'm dressing based on yesterday's weather. And except like maybe 2 days in a year, it's just the perfect way of dealing with this. You can make this experiment and see. So it's not the only place where we will use this approach. So let's talk a bit about Kanban, about cycle time distribution, how to predict, and then about advantages and disadvantages. Why are we talking about Kanban? Well, because we need to discuss a bit about cycle time, and cycle time is most often discussed in the context of Kanban. It doesn't have to be that way, but we need at least a start and an end point, and that's where Kanban is useful. And important things about Kanban, many people understand by Kanban that you are creating a board and then you move stickies on the board and that's it. Or you move virtual cards over a virtual board. That's not what Kanban is. Kanban is a process for continuous improvement. And the fundamental cycle in Kanban is you identify your process, you visualize the process, you measure things, one of them being cycle time, you have other things that you measure, and then you improve. And then you repeat, because the improvements change your process. So you basically go back to the beginning, change your process, change your visualization, measure some more, improve some more, and repeat. And you are watching for various problems. These are some examples of categories that you look at. Flow. So are things getting stuck? Are things not flowing and instead just stumbling, getting stuck from here to there? Queues, are there places where you have a lot of items waiting for the next steps? Blocks, are the things that are blocked? Do you have bottlenecks? Quality problems, all kind of things. So you can look at a lot of dimensions on a Kanban board. But we'll focus on the metric, and that is cycle time. And the way you can visualize it is, let's say you have a backlog where you have all the things that are requested to you from the outside of the team. And those can be bugs, can be features, can be improvements, it doesn't matter. Internal changes, technical improvements, architectural refactoring, everything goes in the backlog. And then you start working on those and they end up in production. Now, the way you measure the cycle time is from the moment you start working until they are done. So ideally, the done would mean in production and used by customers. Sometimes, though, I have to mention this as a caveat, some companies have like fixed points when they deploy to production and so on. And in that case, at least for a while, we measure until the point when we are ready to develop. So things are prepared for the next window of deployment. These are companies that don't use continuous delivery. And Kanban, if you are using it properly, will force you to eventually go to continuous delivery, because you're trying to optimize these times, and things getting stuck before going to delivery, it's a problem. And it's a problem because not only because the value doesn't get in the hands of your customers earlier, but it's also a problem because it's harder to predict when you will be done, because you have this variation of waiting time. You have, on average, let's say, every week you have some, or let's say every 2 weeks you have a deployment window. This means that on average 1 week will be lost waiting in your cycle time. And that's a problem, right? It's something that you need to address. But I know, yeah, it's not always that easy. Not necessarily technical. Sometimes there are some technical issues, but it's not always that easy, usually from a psychological perspective, trying to figure out the ways to get there. All right, so then let me explain to you how I've used it in the past. I've actually used it with a physical board. You can, of course, use this with a virtual board, like a tool or something like that. But with a physical board, it's pretty easy. When you start things, you write on post-its. This is the time when it was started. When you end things, it goes in production, you write on them. This is when it was done. You compute the cycle time. Now, another caveat here, you might want to remove weekends and days off, because they also introduce a bit of variation in your cycle time. So particularly if you want to use it as an improvement or as a predictor, the variation introduced by weekends and days off is not helping. So here I didn't take into account the weekends and days off. I just computed, cycle time 12 days just to simplify things. But you might take that into account. Now, after doing that, what we are doing is we'll build a cycle time distribution diagram. And the cycle time distribution diagram looks like this. What we have is on the horizontal axis, we have the cycle time. On the vertical axis, we have the number of items. And on the horizontal axis, we'll have cycle time of 1, 2, 3, 10, 20. And on the left, we have number of items. In this case, I went up to 6, but of course they can go all the way to whatever number you have there. And this was, in our case, it was a big wall. And basically when we were done with an item, we did a retrospective. After the retrospective, we moved the item to the corresponding place on this graph. And in time, we got to see the graph building and getting close to make some predictions. Of course, if you're using a tool, it can build things for you. Or you can very easily use Excel or something like that to build this. And I just want to show you that you can do it really easily with a physical board as well. So what does this mean? Well, you see that you get some items. First of all, what you'll want to do is to make retrospectives focused on the items that you want to reduce the cycle time for. So for example, if you have an item that took 20 days, you might want to look at it and say, okay, why did it take 20 days? What could we do? So if such an item comes to us next week, what would it do differently so that it takes less than 20 days? Okay, that's the question that we are asking. We never we cannot change the past, but what we want to do is to look at how we can improve for the future. This is the first thing that we would do, and that's part of the continuous improvement element of Kanban. And then what we want to do is to look at this and say, oh, cool, how can we use this to predict? And it turns out that sometimes if you have a process that is relatively stable with relatively few fluctuations, what you'll end up with is a number of normal distributions. 3 seems to be a typical number. You get a small, medium, and large normal distribution, but you might get more or less as well. So if you don't get a normal distribution, it might happen that your process is has a lot of fluctuations, and those fluctuations come from various reasons. And you need to look at the source of fluctuations and try to eliminate them if you want to get more predictability. Right. But we'll see how to measure your error in a moment. So you might get that. And then you can use, if you want, you can use a bunch of statistics to deal with this. You can use the median, and depending on how many sigmas you want to be, so how close you want to be to the center, and so on. You can do a lot of calculations. Or you can apply some simplified methods. And here are 3 simplified methods for prediction. Method 1, our every cycle time is 7 days. We'll assume that we don't have anything in progress, because if you have something in progress, then you need to use past metrics in order to estimate when it will be done. So you basically go back to when you started, you look at those items and you say, oh, this is how long it will take us to get done. Or you just estimate normally and assume we'll still have, 3-4 days to finish these things, and then let's compute for the next things. But I'm simplifying here because otherwise this will get very long. So our every cycle time is 7 days. We have 0 items in progress. Our next 5 items will therefore take 35 days. Pretty simple, right? Now, this assumes, as you may notice, this assumes that you're doing 1 item at a time. And maybe you'll be doing more. So you can factor that into your computation as well. On the other hand, well, if your every cycle time is 7 days, most likely it will take 35 days, no matter how many you do in parallel. Because that's another thing with Kanban. It's based on reducing the work in progress. Ideally, you do single item, right? Which sounds, I know it sounds weird, but ideally you do a single item. And if you do multiple items, what happens is that your cycle time tends to increase. There's a law about this. Basically, the more items you have in progress, the larger the longer the flow time will be. And that's basically what this is. So, of course, you can adjust this based on your data, but this tends to be a fair assumption. The second method is, once again, we'll assume that we have nothing in progress. Our average velocity is 3 items per week. So the next 5 items will take about 2 weeks. Right? You can use it the other way around. There's no mention of cycle time here. It's
similar with velocity in Scrum, only instead of using story points, we use items. And if you are using story points now, one simple way to do this would be to, for your next sprints, let's say you take 3 or 4 or 5 sprints, count the items that you have in your sprint backlog, do your estimates, and then see how when you've actually finished the sprint, look at how many story points you've actually done, and also count how many items you've actually done. And use the two to try to predict for the next sprint. So basically run this in parallel and see which one of them is more predictable, has fewer errors. And if the error is the same, you can definitely choose the one that takes you shorter, right? Counting the items is a shorter way of making the estimates than doing the story point estimation. Now, this doesn't mean that you won't discuss the items, but that's a completely different story. You can discuss the items in BDD, in BDD style meetings, where you have a tester, a programmer, a business analyst, and you write down the cases. That's a perfectly valid way of detailing them. But you could start by counting them, making the sprint planning like this. And then the next steps is fundamentally figuring out what you need to do. That's another way. And since I've mentioned BDD, yet another method for doing a metrics-based prediction would be to count the tests that you need to write. The tests in BDD, the BDD style tests or the BDD level tests. BDD is behavior-driven development, right? So because those, or the acceptance tests, let's put it into another way. Because if you are talking about if you are counting the acceptance tests, they will give you a sense of complexity of the problem. The simplest user story is the one that only has one acceptance test. It doesn't make sense to have only stories that have one acceptance test. But if you count the acceptance tests, they are a pretty good, or they could be, try for yourself. From my experience, they are a pretty good predictor of the complexity. So there's just an extra method of estimating based on metrics. And the third method, based on past experience, we classify 2 items as small and 2 as large. So we have 4 items. But what we've done in this case, we look at the small items from the past, we look at the large items, and we find some common characteristics. In a project I worked in, we identified, it was a web application, MVC style application, and we identified the small items were the ones that were requiring only changes in the user interface. Medium items were requiring changes typically in model view and controller. And large items were requiring more changes than just adding a field or something like that. So we identified a bunch of things, and you always have outliers, things that don't match everywhere. You try to match them, but there will be some variation there, of course. So you can analyze the small items, you can analyze the large items, and figure out what are the categories, and then for the next items, figure out where to classify them, and then take into account the average cycle time for small, the average cycle time for large. Or if you want to be more precise, you can take the median for small, the median for large, compute the standard derivation, and so on, if you want to play around with statistics. In that case, we use a simplified version. So we have every cycle time for small items is 2, every cycle time for large item is 15. So we expect all 4 items to be done in 2 times 2 plus 2 times 15, which gives us 34 days. This would be another way of predicting. Now, there are let's discuss a bit about some advantages and disadvantages. One of the advantages that I found with this method is that you don't negotiate, right? You have the numbers, you show the numbers, you show why you believe these items are small, these items are large, and there's no negotiation on the estimate itself. The negotiation can definitely happen, but in terms of scope. Usually what happens is when you show, we have 2 items that will take 15 days each, your product owner or business people who are requesting things from you will say, but we can actually live with less. So let's try to do this first. And then you start discussing, how to split stories, basically, or how to solve a smaller problem rather than a larger problem. It's fast because you just compute things. And another advantage here is that it's a method that you don't have to use it immediately. You can use it in parallel with what you are doing now for a while until you prove that it's actually correct. Or you can look at if you have past data and your past estimates, what you've done, your past cycle times, you can use past data to evaluate the prediction error. And if the prediction error for your current estimation is smaller or equal with the prediction error with this type of method, then maybe it's better to switch to this method because it will give you same results or better results with less time. So less investment. And this will give you more time to focus on building stuff, which is what people expect from us. Now, there are some disadvantages, and I've seen them in practice. You need to do some number crunching, particularly if you try to do statistics and such. It gets a bit complicated. If you're just doing like addition, multiplication, and so on, it still can be a bit, not necessarily the nicest things to do. It feels out of control in a sense. It feels like the system is working itself, which of course is correlated with the fact that it's fast and you have no negotiation, but for some people it doesn't feel that good. Some people feel better if they analyze it and they look in detail and and of course normally we wouldn't care necessarily about these feelings, but they might be important in your team. They might block the adoption of this method. So, it's important to take this into account. Another thing is that this requires continuous improvement because once you have these numbers, a normal thing to ask is, okay, let's do this better. So you will be forced into a continuous improvement. Once you start measuring things, you'll need to improve them, you'll need to manage them. And some people just want to build stuff. I'm not here to judge. I love to improve, to get better, to be a better version of myself, a better version of my team in time. But that's up to you, right? And sometimes, it can lead to other types of pressures from management, because once they see these numbers, they might say, okay, so let's now do 10 days instead of 20 days for the large items, which is, it's a good conversation to have. It's not necessarily always possible quickly, easily, and without a lot of other changes in your organization. So take this as a caveat. All right, what do you think about this? Do you want to hear more about estimates, about other method of estimating, of predicting, and so on? Let us know in the comments. I'm always happy to read the comments, to answer to them. So yeah, let us know. And if you have any other questions that you feel that I could explain, let me know. Thank you kindly for the view, and until next time, remember to think, design, and work smart.